Do you listen to me?
Yes, sir.
How many students are online?
3.
Okay. Share with them the Zoom ID, right?
Fine, sir.
You have the Zoom ID with you right now?
Yes, sir.
Share it with all the students in whatever possible way. बोर्ड दिख रहा है?
सर हो रहा है शेयर? यस सर, दिख रहा है.
Okay, okay. दिख रहा है बोर्ड?
Yes, sir.
Okay, okay, okay. You know what we have been doing?
Projectile motion.
Projectile motion, yes. So, look at this. Number one, what we want to do here, right today, we have a, what you call as a tower of height h. And from here, we throw an object with velocity v0. It falls like this and hits the ground. It hits the ground. Our question is, what is velocity here after time t, and how much horizontal distance it has covered, and how much height it falls, that is this y. When the object reaches here, it falls this height, it falls only y. It does not fall this distance, it falls only this vertical distance y, and how much forward it has gone x. And then I want to find its range also, how much away it will go from the bottom of the tower. And also I want to find this Vx velocity and Vy velocity. Then I want to find at what angle it hits the ground. I want to find this angle also. I will also find from here to here what is time. So many things I want to find from this figure. I want to find this Vx, Vy, then I want to find this x, I want to find this y, I want to find time of the projectile, I want to find this final velocity also. I want to find even the theta, the angle what the velocity makes with the horizon. These are the things that I want to find. And what is given to me? What are the given conditions in the problem? Given is, it is y direction, it is origin here taken. Can you tell me what is V0x? The object is thrown horizontally in the forward direction. What is V0x?
V0.
Just V0, good. Not any V0 cos theta, because the total velocity is in the horizontal direction. So V0 initial horizontal velocity is V0 total.
Yes, sir.
What is V0y?
0.
Initial vertical velocity 0, good. There are some students which give me the right answers. Okay. What is for every moment g is downwards? The particle has downward acceleration, downward. So can you tell me what is Vax?
0.
What is Ax? 0, good.
0.
What is Ay?
Minus G.
Y is upwards, so Ay is minus G. This is given. This is given. So, first of all, let me find this x in a very simple possible way. Given all these things, I want to find x. So, what formula you can write for x? Displacement in the x direction.
Sx
V0xt plus 1 by 2
plus 1/2
axt square.
Ax.
This cut finishes because x is 0. So x is equal to V0x,
Yes,
that's
sir.
V0t. V0
Yes, sir.
t. This
T.
over. This is over. Equation number first. Now, what is y?
V0yt.
नहीं, have a look. मैं आपको बताता हूँ. Y, it is minus y. Why it is minus y? Can you tell me that? Okay, chalo. No. Okay, I will do it the way you think. You understand it or you like it to be. कहाँ जा रहे हो? It is y equal to, have a look. Y is equal to V0yt plus 1 by 2 ayt square. That's what you want, right?
Yes, sir.
Okay, y is equal to, this is 0 because of initial velocity,
Yes, sir.
minus 1 by 2 gt square, right? Or
Yes,
y
sir.
is equal to minus 1 by 2 gt square. This negative means nothing, but the particle goes in the downward direction.
Yes, sir.
Because it is 0 here, origin is here, and this y is down the origin, therefore it is negative. Okay?
Yes, sir.
Now, let me find this Vx. Now, Vx is equal to V0x plus axt. But ax is 0, so it is V0x, and it is just V0.
Yes, sir.
Now, what is Vy? V0y plus ayt. This is 0.
Minus GT.
That's minus gt. Means this Vy is have the downward direction. That's the negative sign meaning. Right?
Yes, sir.
Can you find what is V now here?
Yes, sir.
That is
Under
root
root
of-
of Vx square plus Vy square.
That's V0 square plus g square t square. Is that
Yes,
right?
sir.
This square plus this square. What
Yes,
is
sir.
this? What is this alpha
Yes, sir.
angle? Tan inverse
Tan inverse Vy by Vx.
Vy by Vx.
Vy by Vx.
That is Vy by Vx. And you can substitute and get the answer.
Yes, sir.
You can substitute and get the answer. Okay? Acha. Now,
Yes, sir.
let me find the total time taken from here to here. When the particle falls onto the ground, can you tell me what's the displacement? Okay, let me make a new figure
Displacement.
so that this becomes very clear to you. Have you copied this all? Okay, I am going to upload it also.
Yes, sir.
There you can copy it afterwards. Have a look. I will make a new figure and use a very simple equation to find the time. This is a tower, and this is object thrown horizontally with a velocity v0, and it falls down like this. It is h, and it is origin here, and suppose this is what you call as range, or this is x. Now can you tell me what is the displacement when the particle hits the ground? Is this the displacement, this path?
No.
No. This is the displacement.
It will become the triangle, right angle triangle.
This is the displacement, right? And what is the x component of this displacement? That is this.
Yes, sir.
For this displacement, this is the x component. And what's the y component?
Yes.
This is the y component?
H.
Minus h, down the line.
Yes, sir.
So when the particle hits the
Yes,
ground,
sir.
you can have relation for this displacement, or you can have this relation for h or r, because you have displacement equation, and you have x component of that displacement equation and y component of this displacement equation. So what is the equation that I can write?
Yes, sir.
Sx is equal
S equal to under root of
v0x t plus 1 by 2 ax t square. Sx, that is r, from here to here, that is r, that is v0x, that is v0, that is v0 t. Equation number 1. What is sy? That is v0y t plus t is the same for horizontal and vertical. T is the same from here to here. The time taken by
Yes,
the
sir.
displacement, time taken by the y distance, time taken by the x distance, even time taken by the path is the same, and simultaneous time t, right?
Yes.
Those are not different times. Time is only the time connects this and this and this. Otherwise, there's no connection between their independent equations. This is 1 by 2 ay t square. Now, what is sy? Have a look.
Height
What's sy?
minus h.
Minus h. That's very important.
Minus h.
Yes, this is 0 plus 1 by 2 minus gt square. If you make a mistake of writing plus h here and minus g, that will not make sense, because t will not be negative.
Yes, sir.
If you write plus here,
Yeah.
minus here, it will not make sense. If you write plus here and also plus this g, that will get you the right answer, but you have made two mistakes, and two mistakes don't make a right. Therefore, it is negative, and it is also negative to get the things in the right way. So t square is equal to 2h by this g, and t is equal to root of 2h by g.
G.
Is that right?
Yes, sir.
Now, what is r? Range.
V not into t.
This t you substitute here. You will get the range equation, that's r equal to v0 root of 2h by g. It is very interesting that time of fall does not depend upon this initial horizontal velocity. It is an interesting situation.
Yes, sir. It's same as the free fall.
It is, yeah, yes, that's right. It is same as the free fall. And it is also a free fall in a very meaningful sense of the word. Okay. Let me do one. This is an example, and it explains you everything. What is happening? Okay. Now, there is a second example in projectile motion. That is, if you throw an object from certain height again, and you throw an object with this velocity at an angle of theta with the horizontal, not horizontally, and the object will fall like this. My question is, first of all, write down the equations of motion. Write down the equations. of motion. That is all. Once I write down the equation of motion and V0 will be given, theta will be given, and you substitute this theta and V0 in those equations, and you will determine all the unknown parameters. The wrong way of doing the things will be find the time from here to here, write one equation from here to here, and then write one more equation from here to here. That's the wrong way of doing things. The correct way of doing things will be to write a single equation from here to here. After all, it is falling again under gravity. So
Yes, sir.
I will be asked to find what is this x and how much time it takes to fall from here to here. So I will give you the equations which will determine this x, which will determine time in a single equation. That's all. You try to understand it, and you see some of the books or maybe some teachers, they explain it. They give one equation from here to here, and then they give one more equation from here to here. But that is not the good way of doing the things. Shazia was last time telling me that it was wrongly done. That's why I stress this. It should be done in a correct way. Now have a look. It is obviously, it is situate, it is the origin. And h is below the origin, therefore it should be taken as negative. When something is below the origin, that distance is taken to be negative. And this is positive distance because it is in the positive direction of the x-axis. Right? Now, can you tell me, it is an object falling and you know its acceleration is downward, that is g. What is ax in the process? Acceleration in the horizontal direction, 0. What is ay?
0.
Minus g.
Minus
Acceleration
g.
on this is minus g. Horizontal is 0. And what about v0x? V0
cos theta.
What is v0y?
V0 sin theta.
Theta will be given, v0 will be given, and you can find it is their value. A horizontal velocity, initial horizontal velocity, and initial vertical velocity. Both the things will be known to you. If you know v0, its numerical value. If you know theta also, obviously you can know these two values. It's not a big deal. It is v0 cos theta. What is v0y? v0 sin theta.
Sin theta.
That's right, v0 sin theta. If I ask you what is vx here, you can find it. What is the vy of this? You can find it because you know the vx formula, you know the vy formula. If I ask you what is this theta, that you can also find. No problem. But how to find time? Let's see. When a particle falls from here to here, what's the displacement?
We will join the points.
This is displacement. What is the x component of the displacement? This?
X. Yes, sir.
What is y component?
Minus h.
Minus h. So this is why. So don't bother about the path. Bother about the displacement. And you have already the displacement equations. You have the vertical part of the displacement. You have the horizontal part. If you have the equation for this, that equation will have two components, this and this. So can you tell me what is sy? v0 yt plus 1 by 2 ay t square. Is that right?
Yes.
What is t? What is sy?
Sy is the vertical displacement.
H. Isn't that?
Yes. Yeah, minus h.
Okay. It is minus h. And what is t?
The time it takes to come down.
Yes, time it takes to come from here back onto the ground. Because h is the total vertical displacement when the particle hits the ground. So it is the total time from here to here in which the particle has covered the vertical height h. Yeah, vertical distance, vertical displacement h. So if I write s5 is equal to minus h, I should write v0y is equal to v0 sin theta into t plus minus 1 by 2 gt square. Because it is minus g, it is negative. This equation will give you time. Because h will be given, v0 sin theta will be given, it will become quadratic in time. G will be given like 10 to pi t square. It will be given. So you have a neat and clean equation quadratic in time, and that will certainly give you two values of time. and you know what are those two values. Those two values will be, one will be this time from here to here, other will be from here to here. So it is so simple. So this is the great equation which will tell you everything. Now what about x?
Sx equal to v0x.
X is equal to v0 x into time, because there's no ax. So every time writing ax and cancelling it off and crossing it is not good. It is now x equal to v0 xt, because you know there is no acceleration in this direction. So you should try to write this very quickly in a straightforward manner. So v is equal to v0 x, you know,
v0 cos theta.
v0 cos theta, and it will be given to you anyway. I mean, v0 will be given, theta will be given, and time, whatever time is the same.
Yes, sir.
For this and for this whole, and time is the same. So time you can substitute from this equation, whatever time you get from here.
Yes.
That is all. It's very important. Please mark it well. प्लीज मार्क इट वेल, इसको कॉपी कर लो, इसको कॉपी अच्छी तरह से कर लो. Have you copied this?
Yes, sir.
Okay, good, very nice, very nice. Take your time. Okay?
Yes, sir.
That's right. Okay, good, very nice. Now, let me go to one more example. Third example. Let me find the equation of motion of the projectile. Equation of motion of projectile. First, here you will understand what we mean by equation of motion of projectile. Let us understand what we mean by equation of motion. Have a look. It is x, it is y. And particle is thrown from the origin like this with velocity v0, and it goes like this. It is projected at an angle of theta, and particle is here, then it is here, then it is here, and it goes and goes and goes and hits the ground. What I want to know what is this path? Is it this path a straight line? No, it is not. Is it a parabola? Let us see. Is it a circle? Is it an ellipse path? What kind of a track it is? That we want to know. Path. Is the path, it follows a straight line? Yes, it is a planar path, that we know. It is in the xy plane. But what kind of path? Straight line it is not. Parabola, let us see. Is it hyperbola, parabola, ellipse? That can be obtained by when we find equation between y and x. That is all. If we find equation between y and x, how y varies with x, that will give us the path of the particle. So suppose y is equal to mx plus c. So this will tell us straight line. It is a straight line. If it is x square plus y square is equal to suppose a square, then it will tell us it is a circle like. If it is x square by a square plus y square by b square type is equal to 1, then it will tell us it is a ellipse. But we have to see relation between y and x. If it is quadratic, y is proportional to x square, then possibly we may say it is a parabola, right? So we have to see. So how to do that?
Yes, sir.
Now see how to do that. Tell me what is initial velocity in the x direction? V0 cos theta.
V0 cos.
What is initial velocity in the y direction?
V0 sin theta.
It is V0y. It is V0x. Okay. Suppose particle reaches here. At any time, it may reach here, 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 not at the top position because there's a particular position. At any position. So I want to find its coordinates here. Its coordinates is x and y. What is x? Draw a perpendicular. From here to here, what is it? X. From here to here, y. What are its coordinates?
X comma y.
X comma y, because x is the distance from the origin in the x direction, then y coordinate is how much above it is from the y axis, that's y coordinate. So its coordinates are x and y. If we find the relation between these two coordinates, that means we will find the path. So how can we find that? Let's see, have a look. Try to understand me in a very clear way. Here, what is x? That is V0 xt, and we don't now need to write 1 by 2 ax square to make it 0 later. So it is just V0x, right? T.
Yes.
Or should I write 1 by 2 ax t square?
No, sir.
But then I have to say ax is 0, then delete it, right? So it is V0xt is the good equation. Equation number 1. So what is y? This y distance, vertical distance.
0y.
V0 yt plus 1 by 2
plus 1
ayt square.
Ayt.
Equation number 2. Equation 1 will be x is equal to V0 cos theta into t. Equation 2 will be y is equal to V0 sin theta t minus 1 by 2 gt square, because ay is minus g. Now I will manipulate these two equations. I will manipulate these two equations to find the equation of motion. That will tell me what path that projectile follows. Is that right?
Yes, sir.
That will tell me what path it follows. And that then you have to remember that in any projectile motion where g is supposed to be constant, the projectile of a path is something that I will find from here. Okay?
Yes, sir.
Right. Let's see. See what I will do, because these I need, therefore I keep them visible from here. So y equal to V0 sin theta. T I will substitute from here. So T is from here. That is T is equal to x by V0 cos theta. That I will put here, x by V0 cos theta minus 1 by 2 g. T square is x by V0 cos theta whole square. So what is y? Y is equal to V0 cancels, so it is x tan theta minus sin by cos tan theta. Right? Now 1 by 2, it is g, it is x square by V0 square cos square theta.
Cos square theta.
Yes, because this square and this square, right? Now look at the equation.
Yeah.
This is quadratic.
Yes, sir. Parabolic.
Therefore, the projectile motion follows a parabolic path. A parabolic path. Is that right? You understand that?
Yes, sir.
Okay, I will put it other way around also. I'll put it other way around. Now see, I will put it other way around. But now see, this equation you need to remember. This equation you need to remember. I'll put it other way around. Y equal to x tan theta minus 1 by 2 g x square by v0 square cos square theta. Y equal to, if you put this common x tan theta, what remains inside? 1 minus 1 by 2 g x square v0 square divided by what? X tan theta. Yes. What is missing here? You just, when it's common, it is 1, and it is missing here, you just put it down in the denominator, right? Now this cancels off, and y equal to x tan theta is 1 minus 1 by 2 gx by v0 square cos square theta. This tan theta is sin theta by cos theta.
Exactly.
Yes.
One cos term finishes off. So y is equal to x tan theta. 1 minus what?
1 by 2. No, 1 by v0 square. gx by v0 square into. ठीक है.
समझ आया कुछ?
Yes, sir.
मैं समझाता हूँ. Have a look. R equal to v0 square sin 2 theta by g. Here g is in the numerator, but v0 sin 2, it is cos sin theta. Twice v0 square, twice sin theta, that is sin 2 theta. So it is R, x is there, but R in the denominator, because R is this. It is v0 square twice sin theta cos theta by g. It is same thing as R, but R inverted R, because g is in the denominator, but here g is up, and twice sin theta cos theta v0 square is in the denominator, so it is inverse of R. So this is one more equation. Do you understand that?
Yes, sir.
Try to understand this. This is a very important equation. Have a look. Or should I do it once again?
No, sir.
Taib. Hello, Taib.
No, sir, it's fine.
It is fine. It should be fine. Now see here, this g here, it is twice v0 square sin theta cos theta in the denominator. Therefore, it is inverse of R, because R is this. It is inverse of R here.
Yes.
Okay, but this equation is very important. I will tell you the importance of this equation like this. Have a look. Suppose you have a projectile, and and the question asks you, it passes through a point. Suppose that point is 4, 3. Right? It passes through the point, which is 4, 3, means x is equal to 4, y is 3. And you know it is angle theta maybe 30 degrees. Right? And you are asked to find the range. Ordinary equations will not give you the answer so easily. The question is, a projectile is launched, it passes through a point of 4, 3, it is launched at an angle of 30 degrees, find the range. But the question I make, it's an arbitrary question. Maybe if I launch something at an angle of, say, 30 degrees, it may not pass through 4 and 3. That is very much possible. But suppose at any angle, it may pass through a point. You may be asked, what's the range? Now see here. It is 4. It is 3. It is 4. So 4 is x, right?
Yes.
3 is y.
3 is y. And this 4 is again x. And this theta is this. You can
30.
You understand my point?
Yes.
Yes, sir.
This may be one of the difficult questions that could be asked at IIT level, but the answer is very simple from this equation. In fact, these questions were asked in the past, and when the students got these questions to me, I had to develop this equation to solve such questions. Is that clear to you now?
Yes, sir.
Okay. Now, one more important point of this equation. See, this equation is y equal to x tan theta 1 minus x by r. If y is equal to 0, I mean, the projectile has hit the ground. So what is y here?
0.
What is y here?
0.
So if y is 0, what should be x? What should be this x? Range.
Range.
When y is 0 at the last moment, then x should be the range. Now see, if y is 0, that means 1 minus x by r is 0. If y is 0, that means this is 0. So it is 1 is equal to x by r. That means x is equal to r. There was a question asked at the IIT level that y is equal to x square minus 1. Y is equal to x square minus
1.
1. What is the range of the projectile?
Okay.
And students started working with all kinds of equations that they had at their in their arsenal. I mean, with them. But those equations could not give them the answer. So if he says what is the range of the projectile, you must put y is equal to 0. That will give you x is equal to plus minus 1 answer. You see, sometimes it is the this is all about wits, how your mind will work. So if it is a range, total range, then you put y is equal to 0. When you put y is equal to 0, then you find x. So x will give you the range. Is that right?
Yes, sir.
Okay. Now, let me go to simple things now. Slightly simpler things. That is, you know, range is equal to fourth point. Range is equal to V0 square sine 2 theta by G, as you know. The same range is equal to V0 square sine of 2 theta to 180 minus 2 theta. Because sine of 182 minus 2 theta is again sine 2 theta. There's no difference between this and this. Is it? Is there any difference?
No, sir.
I mean, if you say what is sine 180 minus 2 theta, the answer is sine 2 theta. So why not to replace this by this? So V0 square is sine of 2 common can be taken from here. So it is 90 minus theta by G. So if you compare these two ranges, they are the same. V0 square is the same. G is the same. Even sine is also the same. Even 2 here is also the same as 2 here. So what is different? It is theta and?
Theta and 90 minus theta.
So this implies that this theta and 90 minus theta should have the same range. So the projectiles with theta and 90 minus theta angle have got the same range. However, vertical heights have to be different. उनमें क्या है? Vertical heights are different. Even times are different. You follow my point?
Yes, sir.
Now, I want to give you examples. Now see, have a look. Suppose there is a range at angle of 30 angle of 30 range is this. Angle of 60 will be like this. Suppose it is 60, it will be like this. Because if theta is 30, 90 minus theta, that is 90 minus theta is equal to 60. That means 30 and 60 will have the same range. Vertical heights are different. Even times are also different, because time is equal to twice v0 sin theta by g. अगर थीटा 30 है तो टाइम कुछ होगा, अगर थीटा 60 है तो टाइम डिफरेंट होगा. तो h is also equal to v0 square sin square theta by 2g. Right?
Yes.
So if theta is 30, h is something, and if theta is 60, h is different. So times and heights will be different, but horizontal range will be the same. That is one point. Another point I want to tell you here. Another interesting thing. Suppose you have range is equal to v0 square sin 2 theta by g. For what angle theta the range will be maximum?
45.
For what angle range will be maximum?
45.
That will be, this cannot, for the same velocity, for the same g, of course g is the same. What you can change? You can change this 2 theta angle. So 2 theta, when sine of 2 theta is maximum, when its value is 1, sine of 2 theta ka maximum value 1 hai. So that should be sine 90. So 2 theta should be 90. That will make theta is equal to 45. So at 45,
Maximum range.
the range will be maximum.
If velocity is.
Obviously, you see, if you change one parameter, other parameter has to remain constant. You can't change all the parameters at the same time and see, and you can just tell the dependence of range on something else. If you want to find the range dependence on velocity, these two things have to be constant. If you want to find the dependence of or with theta, these two things have to be constant. You understand that?
Yes, sir.
है ना? तो ओके, आज के लिए काफी. कल मैं आपको inclined plane पर दिखाऊंगा projectile motion और कुछ examples. That is the end of the projectile motion, and day after tomorrow से हम problem शुरू करेंगे. आपको ये पूरी अच्छी तरह से मैं मुकम्मल करके दूंगा, लेकिन आपको असाइनमेंट भी मिलेगा.
Yes, sir.
ये है जो असाइनमेंट मुझे सबमिट करेगा इस पर Zoom पर, उसी को लेक्चर मिलेगा, वरना मैं उसको यहाँ से ब्लॉक करूंगा.
सर इसमें एक क्वेश्चन आता है, आपने वो देखा होगा, वो परपेंडिकुलर कहाँ पे हो जाएंगी वेलोसिटीज, वो वेक्टर रेजोल्यूशन पे हो जाता है सर.
देख, मैं वो सारे ऑब्जेक्टिव्स और प्रॉब्लम्स आ जाएंगे पहले. आप मुझे क्वेश्चन पूछ सकते हैं, उसमें कोई प्रॉब्लम नहीं है, बट यू कैन आस्क मी क्वेश्चन ओनली व्हेन आई से नाउ इट इज कंप्लीट. Maybe up to that point, all those your questions, the questions which are already in your mind, may be answered by me.
सर मतलब वो वेक्टर रेजोल्यूशन पे ही है ज्यादा.
Nick, that I will use vector resolution. I will use in all the questions where there is necessary, because I have told you कि velocity कब vector कैसे resolve करते हैं, किस direction में zero होगा, किस direction में zero इसका value होगा. So I have dealt with all those things. But finally, when I will discuss everything, each and everything, then finally I will give you one day. You just ask me objectives or problems which you can't solve. Then we can solve them together. There's no problem. Okay?
Yes.
Should I stop now? You want to ask any question, Shahzeeb?
सर नहीं, मतलब
कोई इलेक्ट्रिसिटी का क्वेश्चन है तो पूछो. अच्छा चलो यार, कल वो पहले ही देख कर रखना कि व्हाट यू वांट.
सर वो आपने वो क्वेश्चन फिर दिखाया ही नहीं मुझे.
कौन सा वाला?
सर वो ना, वो जो एच वर्मा पे वो उसका K1 और K2 है, वो वैसे वो दो पैरेलल प्लेट कैपेसिटर्स के बीच में वो डाला है डायलेक्ट्रिक
क्रॉस वाइज से.
हाँ.
अच्छा दिखाता हूँ, चलो कल क्लास में दिखाता हूँ, या आज ही दिखाऊं?
सर अब आप जैसा मुनासिब
चलो
समझे।
ठीक है, कल दिखा देंगे वो. That is a lengthier one that will involve a little derivation. I will solve it within 2 minutes, no problem.
ओके सर।
Don't bother. Okay.